the total quantity, we let X be the more expensive item. In the other situation where they told us which one was bigger, we let X be a smaller thing. Here we don't know which one's bigger. So we let X be a more expensive item so that we can let 56 minus X be a less expensive item, and it'll keep our numbers small. All right, let's do this and we'll be done with the hardest one. 5 times 56 is 280 maybe? Minus 5 times X is 5X. And 12 times X is 12X. And what do we do with these two numbers? We multiply across, and then we add down, don't we? This is what we spent on mugs, plus what we spent on t-shirts, is what we spent all together. So our equation is this thing plus that thing equals 378. And I'm not going to work that, but if you work out that equation, we'll find out that X equals 14, and 56 minus X equals 42, just like we got before. We get the same answers. It's just a different way of saying it and a different way of setting it up. Okay, let's do something that'll be, after this, chapter 6 is going to seem like a breeze, okay? This is the hardest thing in the whole semester.
Now, break that on down, the 280 minus 5X.
You want to see the end of it?
Yeah.
Okay. Twist my arm. 280 minus 5X plus 12X equals 378. And we want to solve for X. Well, can we put these two things together? We got 12 of these guys minus 5 of these guys. So how many of these guys we got? 12 minus 5? 7 of these guys. And these guys happen to be X's. Could have been dogs, they could have been cats, they could have been the number 3. But we got 7 of them. And we still got this 280. Is it a plus 7 or a minus 7? Plus 12 minus 5, that's a plus 7, isn't it? Okay, so we combine those X's. Now we want to get the X term by itself and everything else on the other side. So what are we going to do next? Yeah, we want to get rid of that 280. It's being added to 7X. So let's subtract 280 from both sides. And the 280 becomes 0, and 0 plus 7X is just 7X. So effectively that 280 goes away on the left side, and it gets subtracted from the right side. So we have 7X equals 98. We're almost done. What do we do with that 7? Yeah, divide both sides by 7, because we don't want to know what 7X is, we want to know what 1X is. So X is 14. 14 what? What did we let X equal? It was the more expensive items. It was the t-shirt, wasn't it? And we said, once we know that, we subtract it from the total quantity, 56 minus X. But now that we know that X is 14, we can just subtract it from 56, and we get $42. No, 42. Those aren't dollars. That's quantity. 42 mugs. I was going to say, that's an expensive mug. The mug costs $5, but we sold 42 of them.
The only thing that I'm confused on that is the first step on the, why did you do the 5X plus the 12X? Why not the 280 minus something?
The 280 minus what?
Whatever.
Ah.
I mean, why did you start there?
I could have subtracted 280 from both sides, but eventually I'm going to have to combine those X's. So I just happened to start there. But
So you always combine 2 X's or 2 whatever.
2 variable terms, that's right.
If it had said minus that, you would have subtracted it.
That's
As
right.
long as they're two X's.
If it had been minus 5x plus 2x, I'm sorry, what are you asking?
If you had a number, say 280 plus 5x minus 2x, it had been reversed. You still are gonna solve the 2x problems first, right?
Well, you're gonna say, I have
That'd be
5.
3x.
3x, that's right.
And then you did what you need to with the 280.
Right.
Okay.
It's called combining terms that are alike. A term that has a letter in it is called a variable term. A term that doesn't have a letter in it is called a constant term. So we can combine constants and we can combine variables, but we can't combine them with each other because we don't know what the variable is. Does that help?
Yeah.
And then we check it the same way. Okay, let's look at chapter 6 real quickly. This is the first time I've taught this class this way where we actually had